So our separation method was filtration, and basically it separates heterogeneous mixtures. And what it does is you pour your separation mix down a funnel with a filter paper on the top, and then the filtrate, or like the liquid part, will go down and flow down into a beaker on the bottom.
And what do we call what's left on top?
The precipitate.
Very good. So a question for you guys. If you were interested in the quantitative aspect, meaning you wanted to know how much precipitate you collected, what is that one thing you must do? You pre-weigh the filter paper, because once the precipitate gets on, there's no way to figure out the mass of filter paper.
Okay, so our method of separation is hand separation, and this works with heterogeneous mixtures, and the mixtures must be visually differentiated, so they can be separated by its shape, its color, and its mass or something. And
our groups did centrifugation, and so basically the method is used for mixtures with particles of different masses.
So the particles that have a larger mass have a larger force applied on them, and the particles that have a smaller mass have a smaller force applied on them, and so what happens is the heavier particles go on the bottom and the lighter particles go on the top.
And how you do that is you pour the mixture into vials and you place it into the centrifuge. You want to balance the centrifuge, so you never have two vials next to each other if there's no other vials. You want to have them on opposite ends, and if you have four, you place them at 4 opposing slots.
So ours is distillation, and it works based on separating homogeneous mixtures based on their boiling point.
So you start by turning on the water, which is used to condense the lower boiling point substance. And so next you turn on the burner, which boils the substance with the two different substances inside. And the one with the lower boiling point will evaporate, and then the cold water will make it condensate, and then it'll go into the other flask. And then you can take that out, and then you can do the other one and then put a different flask in.
So as you can see in our particulate level drawing, originally it's a homogeneous mixture, the flask with both substances mixed together, but after the distillation, there's two separate flasks, each with the separate substance.
Our separation technique is chromatography, and it's used to separate homogeneous mixtures based on their affinity for a mobile or a stationary phase.
Basically, for the procedure, you need a beaker, a stirring rod, and a piece of paper with the ink on it. And what you do is you put the stirring rod on top of the beaker, and you fold the piece of paper over the stirring rod, over here, and then you submerge the paper in the water, making sure that the ink isn't submerged in the water, but just like the bottom of the paper. And then the water will go up the paper, taking the particles that have an affinity for mobile.
So the stationary phase is when the ink is just on the dry paper, and then the mobile phase is the water moving up, and the water will carry the particles with higher affinity for water up.
Go.
Okay, so this is decantation. It's for use with heterogeneous mixtures. And I already mentioned the separation technique is decantation is basically where you take a mixture which has a precipitate at the bottom and you pour out the water. It's